For today, we're going to discuss the new topic. But before that, let us pray. Converse, inverse, and contrapositive of an if and then statement. So in every day, we are dealing with different situations. This life situation is filled with conditional statement, the if-then statement. Again, if is the hypothesis, then statement is the conclusion statement. Let us consider this statement. If Mr. Flores gets majority of the vote, then he wins in the election. If he wins in the election, what does it imply? What happened if he don't get the majority of the votes? So from the given conditional statement, there are other statements that will be formed by interchanging and or negating the hypothesis. So, to be more understand what we're going to do in that statement, let us have an example. So write the converse, inverse, and contrapositive of the given condition or conditional statement. Give the truth value of the statement. So the first condition that we have, a conditional statement, we have if two angles are vertical, then they are congruent. So the conditional statement, if the two angles are vertical, then they are congruent. It is true. So in conditional statement, we have the form if P, then Q, right? So let us have the converse. The converse of the conditional is the form by the interchanging by the hypothesis and the conclusion. It follows the pattern if Q, then P. It means we're going to interchange the hypothesis to be our conclusion. Then the conclusion will become the hypothesis. So let us find out the converse of our condition. Again, the condition we have is if two angles are vertical, then they are congruent. So the converse, so our if statement is, or the hypothesis statement is the if two angles are vertical. So it becomes to the conclusion. Then our conclusion, they are congruent. So it becomes the hypothesis. So the inverse, the form again is if Q, then P, by interchanging the position. So if two angles are congruent, then they are vertical. Then we have the inverse of the conditional statement. It is formed by negating the hypothesis and the conclusion. It means we should have the inverse. So the form we have is if not P, then not Q. Again, our condition, if two angles are vertical, then they are congruent. So again, the hypothesis is two angles are vertical, then the conclusion, they are congruent. So in inverse, the form we have is if not P, then not Q. So if two angles are not vertical, then they are not congruent. Okay? Next, we're going to have the form if not Q, then not P. So in the inverse conditional, we're going to have the word not in the statement. So again, our conditional, if two angles are vertical, then they are congruent. If we're going to get the inverse of the condition, we have if two angles are congruent, then they are vertical. So the contrapositive, if two angles are not congruent, then they are not vertical. Did you get what I pointed? Again, our form is if not Q, then not P. So conditional statements are either true conditional or false conditional. The converse of the given conditional is false since there are congruent angles which are not vertical. We can easily identify a false statement or false condition by giving only one examples. So this is the statement in the first problem that we have in the first slide, right? The condition we have is if Mr. Flores get majority of the vote, then he wins in the election. So we're going to find the converse of this statement. So the converse of this statement is, the form is if Q, then P. So if Mr. Flores wins in the election, then he gets majority of the vote, which is true statement. Then in the inverse we have the form if not P, then not Q. So if Mr. Flores not get majority, the majority of the vote, then he not wins in the election. Then we're going to find the contrapositive. So in contrapositive, we have the form if not Q, then not P. So if Mr. Flores not wins in the election, then he not get a majority of the vote. So that's it. So let us have this example. Condition, if it is regular hexagon, then it has 6 equal sides. It is true condition. So the form again, we have P, then Q. So we're going to write this condition into converse, inverse, and contrapositive statement. So first we have the converse. So our form in converse, we have if Q, then P. So the answer we have is if it is 6 equal sides, then it is regular hexagon, which is true also. Then we're going to write the inverse. So we have the inverse. So in inverse statement, we have the form if not P, then not Q. So we're going to write if it is not regular hexagon, then it hasn't 6 equal sides. So this is also a true statement. Next we're going to write is the contrapositive statement. So the form we have here is if not Q, then not P. So if it hasn't 6 equal sides, then it is not regular hexagon. This is also a true statement. Another example, if the sum of two angles is 180, then the angles are supplementary. Again, our condition, if the sum of two angles is 180 degree, then the angles are supplementary. So the converse of our conditional statement, if our form of converse, if Q, then P. If two angles are supplementary, then the sum of angles is 180. It is true. In inverse, if the sum of two angles is not 180 degree, then the angle are not supplementary. And the contrapositive, if two angles are not supplementary, then the sum of angles is 180. Again, how do we get the contrapositive? We're going to inverse the converse statement. Statement with the same truth value are logically equivalent. That's a condition and it is contrapositive, are logically equivalent. The converse of the conditional statement is logically equivalent with the conditional's inverse. That's why they are both true. So that's all for our last topic in this fourth quarter. Thank you.